Driven with SQL Server 2016. I'm Chris Austin, the National Instructor Manager at DDLS, and I was mumbling my words there, so apologies. I'm your host for today's seminar. Now, just before we start, a couple of things to keep in mind. We'll be doing some questions and answers at the end of the session, but most of those questions will have to come through the chat. So if you look at the WebEx tool on the right-hand side, you should be able to enable the chat option if you need that. Prior to that, though, we'll just let Ian present. Our presenter today is Ian Morrison, who's been a technical instructor at DDLS for the last 5 or so years, but prior to that, Ian has worked within IT for the last 20-odd years. He holds many certifications. He's an MCSE, an MCCSD, MCT, etc. He also holds an ITEL Expert and Prince 2 Practitioner certifications as well. Originally coming from a background in accountancy, the excitement of IT lured him to SQL Server, I suspect, and he's been working with SQL Server since 6.5, which was pre-2000 at least, and certainly has worked with Oracle since then. You might notice a slight accent with Ian. He's from the United Kingdom. You can work out which part as he talks. He's now based in Melbourne, loves AFL football. Unfortunately, he's a Hawthorn supporter for anyone that follows that code. Loves jazz and also is used to the rain, and you'll work out why when he tells you where he's from at some point during the presentation. So I'd like to hand you over to Ian for the presentation, and we'll take it from there, and we'll do questions and a survey at the end of this process. Thank you.
Hey everyone, thank you Chris for that kind introduction. Yeah, my name is Ian Morrison. I work here at DDLS. I'm just going to run through some slides, and I hope to give you a bit of demonstration as well, just to try and bring some of it to life so you can see some of these ideas that I'll be talking about actually happening. So we've got a broad title of Data Driven with SQL Server 2016. I want to talk around some of the value proposition of SQL Server 2016 and then mention some specifics, just focusing in on a few areas. As Chris mentioned, my background is in accountancy. This was back in the day when, I guess this is pre-Ben Affleck making the accountant look that bit more cool. So I was an accountant back then, working in IT for about 18 years. My background in IT was largely Oracle and development, so a bit of programming. As Chris mentioned, I've been using SQL Server since version 6.5, and I've seen this product change dramatically over the years. I always thought it was a good product, but I think it really is a tremendous product now, very much market leading in a lot of different areas, and putting up a decent fight against Oracle. I've been working with DDLS for about 4 years, based here in Melbourne. Moved down from Sydney last year, so yeah, missing home. I wanted to kick off with this quote from Microsoft CEO Satya Nadella, talking about data as the new electricity. And I think the point behind this is, and this is a remark made to partners at the launch of SQL Server 2016 earlier this year, the point here is to reflect the critical significance of data and the exciting ways that we can harness it. And I guess SQL Server finds itself very much at the heart of this, at the center of all that we can do with our data. So moving on from there, I just want to talk through why SQL Server 2016. What's great about it? What should we be looking out for very generally? And then I'll talk about some specifics that should be of interest to everyone. I want to address 5 points here in terms of why choose SQL Server 2016. The points are there on the screen. I'll just deal with them individually. Firstly, any developer, any platform. What I've done there is just come up with marketing style phrases, and I'll fill in with a little bit of detail. What I'm getting at here is stick to what you're good at. I don't want to learn new skills. I don't want to learn new languages in order to leverage this new power and flexibility. So I want to stick to what I'm good at and use existing skills to build data and analytics infrastructures. I want to be able to tailor this environment to applications and services that I already have. And with this open and flexible platform, I can choose the languages, I can choose the technologies, and I can choose the platforms that work best for me. So I can continue to work with Python, Ruby, PHP, Java, Linux, .NET, of course, without any trade-off or compromise when using SQL Server. Build with any data. I can combine it along the way using data and languages that I'm already engaging with. So I can use Hadoop, I can use Spark, I can work with R programming, I can use Giraffe. Facebook uses Giraffe for its social modeling, Solar, etc. There's a whole range of languages and data sources and technologies that I can use within this SQL Server 2016 environment. Talking about using diverse stores of data, we've really got to think about scale. So I'm thinking about this petabyte scale for data. SQL Server offers a more complete platform capable of managing structured and unstructured data, and that's great. But what we want to ensure is that we're still doing that with a level of security, consistency, and that the data itself is credible. With the demand of a modern data warehouse and big data solutions, this Microsoft infrastructure with SQL Server at its heart can handle all types of data, but can only really do so if we've got the scale. So we're talking here, rather than terabytes, we're talking petabytes, we're talking real-time performance. What I would recommend you check out is the white paper on modern data warehouse. I can provide links to that later on. So we're talking about big scale data. I'd also like to highlight the built-in predictive intelligence. We've got cloud analytics with Cortana Intelligence Suite. We've got R-based analytics for scalable Hadoop, database and data warehouse type analytics. We can run analytics directly in SQL Server with data at source. We've got lots of scope about how we leverage this built-in predictive intelligence. Unmatched security and performance. With SQL Server 2016, we're able to achieve exponential performance gains by using the in-memory OLTP, which in itself isn't new, backed up with high availability and simplified management, and there have been a few improvements to high availability, all within a platform that features, and this is according to Gartner, market-leading security. So we've got, the way I see it, unmatched security and performance. Also, we're extending our data across the cloud for speed and for scale, for relatively inexpensive storage. I'll talk about stretch databases as an example of this, as an option that we can use just a bit later in the presentation. I want to think about some product-wide improvements. And I should also mention that what I'm covering and the order I'm covering these topics is broadly reflective of the 2016 upgrade course that we run here at DDLS. But just talking about some product-wide improvements. I want to talk about SQL Server Performance, data security, availability and scalability, SQL Server reporting along with Power BI, and some data access enhancements. I'll also talk again about engaging with the cloud to revisit this idea of working with stretch databases to try and leverage relatively inexpensive cloud storage. Firstly, SQL Server Performance. There are a few points that I want to highlight here. These are focusing in the main on brand new features, but in some cases I'll be talking about features that have simply improved considerably since the previous version. Firstly, the query store. We all want consistently good response times from queries. Performance reductions could come from anything. They could be the result of outdated statistics, all the way through to maybe limits on hardware. So it's often difficult to track down just what's causing our queries to run slowly. Our users are adversely affected by this, and we're failing to meet our KPIs, and the users aren't happy. So I want to track down what's going wrong, and I want to be able to quickly troubleshoot performance-related issues. Query Store helps us with this. Query Store is designed to simplify the identification of performance outliers and performance-related troubleshooting. You may in the past have been used to using dynamic management views for this sort of work, or maybe Profiler, or probably a combination of several tools. But using the SQL Server Management Studio, I'm able to activate or enable Query Store, and this gives me access to interactive graphics, showing me where my queries are performing best, and allowing me to harness these plans and apply them to that kind of query in the future to try and ensure a fairly consistent level of performance. So Query Store is something that you should have a look at. It's very easy to set up, it's very easy to try out. Operational analytics, whether real time or with a time delay, without the need for ETL, SQL Server 2016 introduces a new type of column store index. When we think about analytics, operational analytics, we tend to think of extracting data from source, transforming it, loading it into a data warehouse environment, or maybe a more consistent database, and analyzing the data from there, using that as our source of read information. But with the adjustments, with the changes made to column store indexes, this gives us the ability for real-time operational analytics in place. This new index is updatable and aims at giving the best of OLTP with an analytics function. So we still have our fast online transaction processing, but we also have the capacity to read data in a relatively static way that's also very fast to read. Some of you may be familiar with column store indexes from 2012, 2014. We have this extended in 2016 with updatable non-clustered column store indexes, and that's what makes a big difference for operational analytics in a sort of real-time context. In memory OLTP enhancements, so improvements have been made to memory optimized table. This was introduced in 2014, so not a brand new feature, but certainly an improved feature. This supports temporal tables, that's a topic I'll talk about shortly, and row-level security, both 2016 issues. But something that's maybe a bit more striking is we're talking about using up to 2 terabytes of user memory, and that's up from just 250 gigabytes of user memory. I say just, it's a lot of memory, but look at the improvements they've made to the size there. With live query statistics, this is switched on through the query menu option in the query analyzer. We go through query, we can switch on enable live query stats in the same way as you may have in the past switched on display estimated execution plan. We can show live query stats. So I can run a query and I can actually see the query unfold before me. I can see the results appear eventually, but while that's happening, I can see the different stages that the query is going through. So there's no doubt that it's using a particular type of join, or it's touching several tables, or it's making use of an index. So I can watch these queries pretty much as they run to make sure that they're doing exactly what I think they're doing, and importantly that they're performing as well as I'd like them to perform. With temporal tables, I'd like to take the opportunity to actually show you temporal tables. We've seen some examples in the past of SQL Server showing historical data. So one way of doing that might have been with a snapshot database, which would show me a point-in-time version of my database. This is taken a little bit further with temporal tables. So what I'll do is I'll kick off SQL Server Management Studio and go through a bit of a demonstration of this. I'll also try and demonstrate row-level security as well a little bit later. So I'll just connect to my instance here. I'll get myself a new query. I'll just make this sort of as big as possible. And I'll just create a database to mess around with. Create a database called Webinar. I'll just run that. What I'd also like to do is use that and build a table, just so that I'm doing this in a sort of fairly clean environment. I'll create a table, and the bulk of this will look like any other create table statement. I'll create a table, I'll give it a name. I'll call it staff in this case, just in this little example. I'm going to use a staff ID as a unique value. It's going to be an identity. It's required, it's not null. And I'll immediately make that my primary key, and I'll also suggest that that's a clustered primary key, which I guess by default we'd be expecting it to be clustered. I'll add a full name column with varchar with the size 100, not null. So far we've got a regular looking table, but I'm going to put in a couple of weird looking column names now. Sys start time, the first of them, and that's a date time 2 data type. But this is generated for me. This is generated always as row start, and it's not null. So what I'm saying in here is that it's not just a field, it's not just a date time 2, but specifically this will get generated when the row is created, or for that matter, when the row is changed, and that's going to be important. I'll copy most of that, and I'll just change it to end time. So sys end time, and I'll just change that to row end. There's a couple of significant differences to what we'd imagine being the regular create table syntax. I'll just throw something else onto the end here. I need this period for, and this is giving me a time range between which changes could happen, inserts, updates, deletes, those types of changes. And this is based on system time. So I'll use system time, and I then just need to convey the parameters on either side of the system time. So that'll be sys start time and sys end time. Just taking them from the fields that I'm using, sys start time and sys end time. And I've just closed the brackets on there, and I'll close the brackets on the create table statement. This table is being created with versioning. I need to switch that on when I create the table. You can alter tables with these statements as well. You can alter table and add in the start time, sys end time, and the period for system time settings, and then you can alter the table and enable or switch on system versioning. You can do that as well. So I'll say with system versioning equal to on. And just before I close the bracket, I want to generate a history table. It will do that for me with a default name. I'll just impose a name just so I can keep a bit more control over it. I've got this history table, and I'll set that to equal to dbo.staffhistory. Close the bracket on that, and just close the bracket on the system versioning idea as well. I'll just run this create table statement, and I've got a table. Okay, so let me just open out the databases here. I've got this webinar database, I've got tables, and I can see dbo.staff, and it tells me very clearly that this is a system versioned table. Okay, there's no doubt about that. dbo.staff system versioned. Included within that table structure, I've got this staff history table, and I can see, as we'd expect, it shares the same columns as the original table. Okay, so let me just add some data to this just to see if it works. So first off, I'll insert into dbo.staff. I'll add an ID, a staff ID, and a full name. And I'll put in the values just to massage my own ego. I'll put in Ian Morrison. I'll spell Ian like that as well because my mum likes it. And add this record. One row affected. Okay, that's good. So I should have one row in my staff table. I'll check that out in a moment. But what I'd also like to do is update this table. dbo.staff. I'll set full name to equal another famous Morrison, Tony Morrison, where staff ID equals 1. So I'll just make a change to the record. So I've added a record which has gone to the staff table. I've made a change to the record which has changed the staff table but ought to have written to my history table. If I select star from dbo.staff, and pretty much at the same time if I select star from dbo.staff history, so I'll just get my staff history table, dbo.staff history. I just saw just earlier. I can see the current record is Tony Morrison. Now I can see that that record essentially started being at, it says there 421. It's going to be like that until, well, the end of time by the looks of things. But then this was the original record that existed from a period of time to the time of that change. So then by engaging with dates, I can then find data as it was at a particular point in time. And the strength of temporal tables is just that I can query data at a particular point in time. That's temporal data. It's well worth having a look at. Okay, let's just jump back into presentation. And hopefully you're seeing what I'm seeing. Temporal data demo. So that's what we just saw. Bit of data security. I'll think about row-level encryption, dynamic data masking, and also the idea of having data that's always encrypted. Dynamic data masking, and we can pick several choices of masks. There's masks built in for email address type patterns or phone number type patterns. With data outsourced, as it often is, or cloud-based, as I guess we're encouraged to do, we need to be more security conscious. Dynamic data masking limits the exposure of sensitive personal information. New syntax has been introduced to help us with this. We've got alter any mask, for example. We've got unmask. You can imagine what that might do. These kind of statements allow us to obfuscate data when results are returned to anyone without necessary permissions. Dynamic data masking is very easy to set up. There's some good syntax built in for us. We've also got always encrypted data. In short, this is designed to reduce the attack area as a means of increasing data protection. Data owners can create a separation between those working on the data and those who need to access sensitive information. It's not designed to be used on entire tables. You don't always encrypt an entire table, but this technology works really well with selected columns, the bank card numbers, tax file numbers, that sort of column. With this feature, data is encrypted both at rest and in motion, and encryption keys are actually held on the client side. Just as a side note, Microsoft have a cloud-first policy. So what we find with Azure databases is that this technology, this always encrypted technology, is already switched on. I just want to jump through a quick demo of row-level encryption, just to show you what that does. I'm demonstrating syntax, partly because I quite like typing syntax, but also because we don't have to wait for too many things to start and stop. There's, I think, fewer moving parts. So let me get underway with this. I've got my webinar database, and I'll stick using that. What I'm going to do in this demonstration is create 3 users. I'll create a manager user. I'll create salesperson 1, salesperson 2 users. I'll then create a sales table, and I'll add some data to it. But what I want to happen is that only sales user 1 and manager can see sales user 1 data. Only sales user 2 and manager can see sales user 2 data. So it allows me to secure data at a role level based on a property of that role. That's to say, in this case, the salesperson's ID. Let me just create some people first of all. I'll create user. I'll create a user called manager. The way that I'm going to do this for the demonstration is just without login. I don't really need anyone to log in as such. I'll create another user, sales1, same idea without login. And I should really just copy and paste stuff. So sales2, again without login. I'm creating these on the webinar database. I'll just create a table, which I'll call sales. And I'll just add in some columns to this. I'll add in an order ID as an integer. I'll add in a sales rep as, now this is actually going to be a sysname as the data type, because I want to be able to develop a function that uses the username as a means of restricting the rows that are returned. So the data type used here is actually sysname. I'll throw in just a dummy product as well, just so there's something to look at. And I'll just leave it like that. So I've created my new table called sales. I've got 3 users involved in this database. Just insert into sales some values. The values, it's 1. Oh. This is going to be attributed to sales1. It's not case sensitive, but just a habit. Sales1. The product, I'll just put Pollybase. And I'm just going to copy that broadly, just to save a bit of time. Take out these extra commas. So I've got 1, 2, and so on. I'll just change some detail. I don't want to change too much, just for convenience. I'll leave the product descriptions as they are. That's perfectly fine. I've got 5 rows affected. And at the moment, if I was to select star from sales, it's no surprise, hopefully, to see that I can see all of those records. And there's a bit of a mixture of who's been selling them. But I just want to expand on this and ensure that the 3 people that I've recently created can also select from that table, because I'm logged in as administrator just now. I'll grant select on, I've got a very small keyboard, on sales to manager, first of all. And I'll do the same for the other 2. So sales 1 and sales 2. That's the bare minimum. I need them to be able to select from this table. But now what I want to try is, now that I've given them permission to select from this table, I'm actually going to withdraw that permission ever so slightly and only allow them to select from their records. In the case of manager, I want her to be able to select any record and see what's going on, regardless of which salesperson has been involved in it. There's a few components I need for this, and there's one component that I find is quite a nice optional extra. I'm going to create a schema called security. This is the quite nice optional extra. It just tidies up the naming convention of the other objects that I'm going to create. I'll create a function called security. So it's using that schema, and I'll call it fn predicate. I'll put in an argument there of sales rep, and this is going to accept a sysname value as its input, and it's going to return a table. And essentially, you might be able to read ahead on this. Essentially, what's going to happen is a user ID, a sales rep ID, is included in here and that will then return a table appropriately cut down for that particular sales user. I need to be able to use schema binding on this. The body of the function is relatively simple. I need to return a table, but I'll do so by returning essentially a true or false. I'm going to select 1 as FN predicate result, so it's going to be 1. So it's true for the row, as we'll see when I apply the policy in the next object. Sales rep equal to username. So that means salesperson 1 is using it. He sees salesperson 1 sales. But if the manager is using it, I'll put in a slightly different test. I'll say username equals manager. And that's a kind of 1 equals 1 type search in that case. So if it is manager that's logged in, manager will see all records. That's how that should work. So let me just create the schema and the function. The error message there, I can just put in a go to put that in its own batch, just to tidy it up. Okay, so I've created the table, I've created the users, I've added some data, and I've created this function. Now, just to get this function working, in essence, just to change this function from merely being a function to being a participant in row-level security, what I want to do is create a security policy. I'll just call it sales filter. I'll add a filter predicate, because this is syntax specifically for this kind of security. The predicate comes from the function. So I've got this function name, security FN predicate. Into that function name, I'm going to use the sales rep value, which is this value here, sales rep, from the table. And when you create these security policies, you create them on tables. So I'll create this on the sales table with, and I just need to switch it on, state equals on. I'll just run that, and it should bring in the function, and then I want to just try it out. So I'll execute this statement as user equal to sales 1. So that's sales 1 from above. Execute the user as execute as the user sales 1. I'll run a select star from dbo.sales and just revert at the end just so I can run as myself thereafter. And I can see sales 1 sales. If I do it as sales 2, sales 2 sales, and just to complete the set, if I do it as manager, I should see everyone, because that's the 1 equals 1 type search, and that's row level security, which I find is quite a good fix for what would otherwise be some quite complicated syntax. I think that's an easier way to answer that kind of issue. Let me just jump back into presentation and think about a few more ideas. Availability and scalability. I'm thinking here about enhancements to always on. So we've had log shipping, we've had mirroring. In SQL Server 2012, we had availability groups. In 2012, this was available in the Enterprise Edition. But we can now use something called basic availability groups, even using the Standard Edition. There are some restrictions to this, 2 replicas, for example, but it does open up the ability to use availability groups even with the Standard Edition. We now have group managed service accounts, which is pretty useful. There's also a database level health detection facility, which can help improve options for triggering a failover. And that's coupled with the ability to define automatic failover targets. Distributed transactions coordinator is also supported, and we can scale out read workloads across secondary copies as well. So it's always on, but it's a lot more flexible. With Azure replicas, we can extend our replication into cloud resources by provisioning one or more Azure VMs with SQL Server, and then adding them as replicas to our on-premise availability groups. There's an Add Azure Replica wizard to help us through it. That's not new, but it has been enhanced in 2016. Enhanced database caching. SQL Server allows you to scale up your database with enhanced database caching. We can use the support for multiple TempDB files per instance, especially useful in a multi-core environment. You can now do this during installation, and that's significant. There's a tab on the installation wizard called Database Engine Configuration, and there's a tab on that at that stage where we can add in multiple TempDB files, which is a real benefit. Moving into SQL Server Reporting and Power BI, I'll show this very quickly just to let you see it potentially for the first time. But if I have a look at let's jump into reporting. We've got Microsoft SQL Server Mobile Report Publisher. I'll just close down SQL Server at this stage. The Mobile Report Publisher is, I think, probably the most significant improvement to SQL Server reporting services. It is actually a separate download that we can download pretty much regardless of whether we've got SQL Server running, but it gives a very clear interface and actually some dummy data that we can play around with. This is giving me the ability to create very quick dashboards. I can size them. I can then, obviously that's the dummy data, but I can go and get my own data from Excel or from reporting services. I can preview that data so I can see what it's going to look like on a tablet or on a mobile phone. So I can change the setting on there to phone, to tablet, or just as a general master. If I jump to phone, you can see the slightly different layout. If I go into that phone structure, I'm getting a narrower screen, typical of a mobile phone. And this gives me access to the report elements that I've used in the master. So we spend a bit of time in the master putting everything we could possibly need onto the screen, into the environment, equipping it with data that's required to use it, and we can then take it from there into the tablet environment and into the mobile phone environment. Another important enhancement is Power BI. So I'll just go to show the Power BI desktop. Just wait for that to start up. And what I want to show just very quickly is how to get data from somewhere. I'll get data, and we can imagine that we could get data from our database, from Excel, from, you can see the CSV, JSON, from SharePoint, which is pretty good. I'll just use a web URL. I'll just go in here and get data from IMDb, from the top 250 movies. This happens. Oh, this could be the queue to move on. Actually, it's running a bit low on time. So if I get imdb.com chart. I think I will just leave that because I'm pretty much running out of time as well. But what we get with Power BI is the ability to bring data in from pretty much anywhere. I'd almost go so far as to say literally anywhere, but I've demonstrated some teething troubles with that already. Bringing in data and then working with modeling. And using modeling, we can add in measures, new columns, etc. But we can also shape the data that we bring in. We can trim out columns we don't need. We can smash up columns to make more sense of them, to make them look like our own data. And then what we can do is just mash that data with anything else. So we can pull data from anywhere. We can do pretty much anything we like with it. And then we can connect it up to data that we already have, and then model it in really easy to use interfaces here within Power BI. You can download Power BI desktop free, and you can use it sort of reasonably well just to try it out without particularly signing up for it. But just to get the full benefit from it, it's certainly worth signing up for a Power BI account. Okay. Some data access enhancements and just a few more slides to go, and then we can finish up and you can ask some questions if you have any. So some data access enhancements. SSIS, SQL Server Integration Services, is and has really always been, in my view, a terrific tool. There's a number of useful new features built into SSIS. A lot of them center around Azure. So Azure supported with a connection manager. We've got Azure blob data uploaded and downloaded, as well as Azure and HD Insights tasks to leverage our big data solutions. We've got Azure Data Lake storage. The upgrade process for SSIS has been improved. The support for always on. There's a new transformation called Balanced Data Distributor, which allows us to run what Azure would call a mapping type job. It allows us to run a large file, slice it into multiple partitions, and then direct those partitions to multiple locations for speed. There's also the Azure Data Factory, which is essentially SSIS for the cloud. That does require a little bit of JSON skill, so a JavaScript object notation skill. So the Azure Data Factory is fantastic, but I'd maybe read up on JSON a little bit beforehand. Talking of which, JSON support in SQL Server was one of the most highly ranked requests with the Microsoft Connect site, and people asking for that to be included in SQL Server, and it's been included in 2016, so following on the footsteps of XML support in the past. So that's pretty interesting. Advanced analytics with R, so our R programming integrated into Transact SQL language, so that data scientists, who are, after all, the rock stars of IT, can develop predictive applications in R and deploy them in SQL Server 2016 production environments. Following on from this, by integrating R in Transact SQL, so because we're using Transact SQL, we can use R in any application that can connect to SQL Server. Imagine the flexibility of using Transact SQL. Well, that's then reflected with the R statements that we need to run. So this opens up the opportunity to create more engaging, differentiated applications that we can then use to try and predict using the machine learning that R opens up for us. A Polybase is a bullet point, but I thought it kind of deserves a bit of a diagram as well. Polybase is terrific, but like a few of the topics that I've talked about, this could easily merit its own webinar. Now, just for Chris, I'm not volunteering to do it, but I just wanted to say a few words about Polybase particularly. I've mentioned along the way a few examples of where SQL Server strays beyond the relational database. I mentioned structured and unstructured data a bit earlier. I talked about getting data from anywhere for Power BI and so on. Polybase is a technology that accesses and combines non-relational and relational data, all from within SQL Server. It allows you to run queries on external data in Hadoop or Azure Blob Storage. The queries are optimized to push computation to Hadoop. Now, what that means is, from a performance point of view, the query optimizer makes a cost-based decision to push computation to Hadoop. This improves query performance because it's able to use the statistics on these external tables to make that judgment. And then if it needs to push the computation out to Hadoop, the MapReduce jobs are automatically generated for us and kick in. And these are massively busy, but massively efficient. The user sitting at one end of this diagram and interacting with Hadoop and Azure Blob Storage doesn't need to understand anything like peg statements, doesn't need to build Hive structures, doesn't need to understand HiveQL, HQL. This is a massive step forward for this idea of getting data from anywhere and building in efficiencies and using cloud storage and so on. It's a really important tool, Polybase, worth having a look at. Just pretty much wrapping it up now with what's new in the cloud. Plenty, I suppose, is the short answer, but stretch databases is one thing worthy of mention in terms of SQL Server. So we're talking here about securely and transparently leveraging, I guess, the infinite storage that we can get from the cloud and using this for our cold data. So we've got our warm data that we're currently interacting with and changing, and we've got our cold data that we're no longer changing. With stretch databases, we can provide longer data retention times without breaking the bank, as your storage is about 40% less expensive than adding more enterprise storage. But what marks this out as distinct from traditional archiving is that it's all done seamlessly. So the data's archived for us, it's pushed out onto the cloud back end for our database. Our backup, if I back up a stretch database, I'm essentially just backing up the local warm data database. It does come with some limitations, so things like data types. Some data types are limited. There's limitations on foreign keys, but the Stretch Database Advisor is a great starting point. And maybe I'd leave you with that if you're interested in stretch databases, select a database and have a look through the Stretch Database Advisor just to see how appropriate it would be for that particular situation. In short, SQL is even better than the original. It's getting better with every release, but I think, certainly for me and representing an organization passionate about training and technology, this is a terrific tool. Hopefully, you'll have got some insights from some of the things I've been talking about. Please visit our website on ddls.com.au, and it'd be great to see you in the future on some courses down the track. Now, I'll invite you to ask any questions if you have them through the chat panel. And apart from that, I want to thank you for your time. Thanks for coming along and listening to what I have to say.
Thank you, Ian. We do have a couple of questions. One was the SSRS Mobile. Is that available in all editions or just the Enterprise edition of SQL Server?
So SSRS Mobile is, in some respects, an entirely independent tool. This is a tool that you can download and start working with data from Enterprise, but you can also be pulling data from Excel. What I would suggest, though, is that you have SQL Server reporting services up and running, just to give you more flexibility in terms of where you get your data from, but also in terms of deploying your finished reports to. So it wouldn't be essential to have a particular version of SQL Server to run this, but it would be beneficial if you had standard or Enterprise edition and SQL Server reporting services running.
Okay, thank you. There was another question. Are there any downsides or considerations for row-level encryption?
Yeah. Now, I think with row-level encryption, row-level security, we've got a fairly easy to use tool, and it's really easy to use because we're working with a function and we're working with tables, and we can kind of see everything in front of us. There's not really any hidden moving parts behind the scenes, but it does rely on schema binding, and with schema binding, we're not able to apply that in every situation because schema binding locks the underlying table. There's restrictions on things like index views. So row-level security is in fact not compatible with tables that have index views. And if anyone's used index views, you can probably imagine the efficiencies that you can get from them. Also within memory OLTP, there's restrictions, full text indexes. If you use full text indexes, there's possibility of data leakage there. So yeah, there's quite a few considerations. I'd rather call them considerations than downsides or problems, and it's just about how we design our data to make sure we get the most from that. So yeah, a few downsides, but not too many.
Okay, thank you. Brian and Steve have asked if the recording of this webinar will be available online. It will be in a few weeks' time. It will be posted to everyone that's attended the event. We have one other question. Does Polybase come as part of the install of SQL Server?
Yeah, so when you go through the install of SQL Server and you're selecting the features for install, Polybase is one of the options that you can check. You can tick and install. What I would look out for though, and it's not really a heads up, it's not something that you, I think, particularly need to worry too much about beforehand, but it will require a Java runtime. When I installed it, I got the error message and then sourced the error message online, and there's plenty commentary about this online, and from that I got directions towards the Java runtime that I had to download and install, and then when I went back through the install, Polybase installed perfectly. So it's an extra feature, that this Java runtime, that doesn't come with the SQL Server installation, but we nevertheless need to have established that before we can install Polybase. But yeah, it comes with the product Polybase.
Thank you. Joseph has asked, is SSRS Mobile exclusively for mobile devices?
Oh, that's a really good question. Not at all. The tools available, I guess, to make it easier to program for mobile devices. You know, if anyone's done any mobile application development, you tend to have to learn quite a range of different languages. Whether it's XAML syntax or it's a C# or a medley of different languages and syntax to make it work. So it's designed to help us with these tools, but it's not exclusively for these tools. Like I said, if you've got SQL Server reporting services, and if you've got, whether it's SharePoint integrated or native mode reporting services, you can be deploying these reports up to your regular reporting services portal and access them without mobile devices. Yeah.
Okay, thank you, Ian. Haven't seen any more questions, so just for everyone.
Got a couple more questions, Chris.
Thank you.
Yep, we've got a question from Douglas. Can stretch databases work to non-Azure systems? Can I stretch in-house to a HCP style solution?
Not at the moment is the, I suppose, negative short-term answer. It's designed for Azure. It's designed to work with the mechanisms behind Azure. I'd be surprised if that wasn't something they were thinking about, but not at the moment.
Thanks, Ian. Question from Brian. How much knowledge do we need to know about JSON language?
Yeah, SQL Server now allows us support for JSON syntax. There was a very good blog written on the DDLS blog recently about JSON syntax that I think would give you everything that you need to know at quite a high level. I can't remember who authored it, but you can probably find that on our blog. I would say pretty high level to engage with tables. That's to say, pretty high level knowledge in terms of storing JSON data and reading JSON data, and it's pretty quick to learn that sort of stuff. I would say SQLServerCentral.com is a great place to go just for some online tuition on JSON. Other than that, we'd be looking at indexing our JSON structures. That's a bit more involved, but MSDN would give you plenty of background in it. So not too much to learn there. It's not really included in any of the mock courses, the Microsoft official courses, other than the upgrade course. And even there, it's not mentioned in too much detail. But I think the questioner would find it pretty straightforward to pick up if he has any experience of maybe writing a transact SQL statement or working with any XML in SQL Server, he would have no trouble picking up JSON structures.
Thanks, Ian. Question from Philip. Are you aware of many major vendors developing tools that use these new security features?
Not so much vendors, but on courses and speaking to people, I've encountered banks that are using some of these new security features. So some students we've had on courses here from some major banks that have been embracing some of these new security features. I think time will tell with this. A lot of it is still relatively new, and I guess we'll just have to see how that pans out. But I don't really have anything definite to comment on there.
Thanks, Ian. Question from Steve. Can I replicate from and into multiple Azure databases in different Azure regions, for example, Australia and US?
Yeah, absolutely. Yeah, absolutely. There's a really good set of kind of, I guess, webinar online tuition clips on Channel 9, Microsoft Channel 9, that some of which deal with this. In fact, there's one in particular this will be on the Microsoft Virtual Academy, which is microsoftvirtualacademy.com. And there's a series on SQL Server presented by Graham Malcolm, and he covers that very issue of replicating to multiple sites. So yeah, maybe check that out on microsoftvirtualacademy.com and look up Graham Malcolm. A lot of his clips are very good, but he has a clip that deals with that specifically.
Thanks, Ian. And Chris, that's the last question I can see, so back to you.
Thank you, guys.
Look, thank you for running the session, Ian, and for everyone for attending the session as well.